Hi guys, and welcome back to another video by George. Recently I did a test to achieve a very accelerated edge retention experiment because today you see a lot of videos doing cutting ropes to see how the edge performs. I wanted to do a very fast test to find out which knife has better edge retention. So what I did is, instead of cutting rope, I cut a whole bunch of different type of metal. For these green cables, there are 56 single conductors inside. In case the green ones run out, I'm going to cut these red wires, each containing 19 single conductors inside. But the conductors are actually thicker than the green wires conductors. I cut the green wires 200 times and the red wires 100 times. After cutting the wires, all of the three knives are still decently sharp. So I think we need to cut something much harder than copper wires to accelerate the edge retention test. So now we're going to cut the tin cans open with the knives and just see how the tin can will wear out the edge. Please be aware that cutting tin cans can be very dangerous, so I do not advise you to try this at home.
So the edge is really fucked up by that.
In hindsight, I would say I should have just started cutting the tin cans instead of the copper wires. The tin cans stall the knives way faster than anything I've cut before. The copper wires are not very good in the edge abrasion test. So I think cutting the tin can would definitely save a lot of time in the long run.
Essentially, okay, at this close to a factory edge angle, it's actually pretty incredible. That doesn't really do much damage at all. See? So this test is not really to suggest that, let's make a pilot hole here.
Eventually, all of the three knives cut 15 loops on the tin cans each. Afterwards, I found the edge is very damaged on all of the three knives, and I tried to cut into some wooden blocks to see how well they perform cutting hard materials like wood. And they performed all very poorly. So initially when I started the test, I wanted to actually do a edge retention / a toughness test. And at the time I figured as the ZDP-189 being 3% in carbon content surely would chip more during the test. However, I was very surprised to see that the only few chips happened just here and there at a very small quantity, but not very big. This is probably largely to do with first, this edge angle is actually close to what Spyderco factory edge angle, which I guess is about 20 degrees per side. And secondly, the ZDP-189 has a good edge retention, and Spyderco did very good heat treat with it. So it's not actually as chippy as you may think, given the 3% carbon content. This paramilitary tool was primarily used to make a pilot hole for the ZDP-189 because I was actually a little bit concerned with the tip breaking off on this knife when I step into cans. So this knife was mostly used to step into the tin cans, which I found that the edge had somewhat damage as well. There are little chips here and there. Again, we can't blame the blade here because the edge angle was actually sharpened by me to probably close to 15 degrees per side. So being a smaller edge angle than the ZDP-189, it really does introduce more chipping possibilities, although it is a 30V steel blade. But having said that, we can see the chips are not very big chips, except that one, which I'm sure was when I knocked this blade onto the very joining part of the tin cans. But other parts were more of a micro chipping. And then we have the S30V on the Benchmade 940, which has more chipping, and partly due to wear, as well as a very thin edge angle. Again, this is probably close to 15 degrees on each side, just like the paramilitary tool. The reaction was very similar. The chipping was more of a sort of line chip than a point chip. What I mean is, like, you can see the chips happen like in a few millimeters sections instead of a chip off the corner like this one, forming a very visible dent on the edge. And lastly, we have this very budget knife, which I got for $5 from a department store. Surprisingly, it did not chip throughout this entire thing. I'm not sure what the steel is on this knife. I can only guess it's 400 series, just like 420 or 440C, that kind of steel. But the steel was actually heat treated to its greatest potential. And there's no chipping, but when the knife actually becomes dull, it's mostly due to its wear on the edge instead of actual chips. These two knives, I believe, are probably close to 20 degrees per side edge angle. So I found that this knife definitely has way better edge retention, although this knife has decent edge retention for the kind of price that you pay. I hope you enjoyed this video so far, and I certainly have way more interesting videos to make, and I look forward to share it with you. I'll see you next time.